Good morning, everyone. Today you have some slope notes to take. So it's going to be really fast. I'm going to show you guys on the camera here. So go ahead and get out your class notes. You'll want to label these today. Today is what, 9/14. These are just your slope notes. This is going to be a refresher from about 2 weeks ago in your math class. You guys have been learning in math about linear lines and the slope on those lines. So let's talk a little bit more how that applies to science. Okay, so first of all, you learned that y equals mx plus b. This is what we call point slope formula. All right, you learn this in math. And so what I want to point out to you is we are concerned right now with just this guy, m. m equals slope, right? So put your math hat on, okay? M equals slope. And when you were in math class, you hopefully learned that slope is equal to y2 minus y1 over x2 minus x1. So it's the change in y over the change in x. So how does this apply to our graphing that we see, or the graphs that we see in the linear curves we're looking at? So first of all, if we take a look at a graph, and that graph has a line on it, boom, okay, the slope of this line is equal to m, right? We call that y2 minus y1 over x2 minus x1. If we are in science class and we're saying, hey, we're going to take a look today at velocity, the velocity of a ball. Once again, not that best when it comes to descriptive titles, but it will do. We know that we need to take the position, which we call x, and divide it by the time. This is the displacement divided by the time. So what does that look like in an equation? V equals position divided by time, right? We could also say d over t, right? Please remember that these top two are exactly the same thing. They mean the same thing. So if we're looking at our equation, is displacement not our y value, and is time not our x value? And doesn't that look very similar to our slope equation? It does. And so what this means is that the velocity, right, in this particular instance, the velocity of this ball is the slope of the line, is the slope of the line. Okay, remember, is means equal. So velocity equals slope. And if we take the distance, the displacement, and divide it by the time, or position divided by time, we're going to get the slope. And this is how your slope equation is applicable in science. And we're going to see a whole bunch of different slopes. Soon we'll see acceleration equals slope. And it really depends on, and what you have to look at is, what is the title, what is the y-axis, and what is the x-axis. Because when we are looking at equations, all right, when we are looking at equations, and just take a look at this, I can write V equals position over time. And if we take a look, the title, right, will always be our variable that is isolated. Our y value will always be on top, and our x value will always be below. So any time I have a graph, I can really put it into an equation, and that equation will give me a slope, and I can just look at this information and change out velocity for whatever I'm looking at. So please remember that in math, right, we have slope, change in y over change in x, and we apply that this week with our velocity. Velocity equals position over time, which is y divided by x. And so anytime we take a displacement and divide it by the time, we're finding the slope of the line, and therefore the slope is the velocity. I hope this has helped clarify a few things and brought in some math concepts that you guys have learned most recently. Please ask any questions during the formal instruction time coming up next. Thanks.